Good morning, students. So myself, JNTUK from AC Department, Chevrolet Engineering College. Today, we are going to discuss about the inverse Fourier transformation examples. Inverse Fourier transformation examples. In the last class, also, we discussed some examples on inverse Fourier transformation. That is, find the inverse Fourier transformation of x of omega by using the partial fraction expansion method, and by using the convolution property, and by using the formula. Okay. Now, another example, find the Fourier transformation of the function. Find the Fourier transformation of the function x of t minus t naught. According to the shifting property, the exponential is multiplied with the t naught. But given here the x of t minus t naught as e power minus t minus t naught and the mu of t minus t naught. How to find out the Fourier transformation? So Fourier transformation formula is the Fourier transformation of x of t is equal to x of omega. Then the Fourier transformation of x of t minus t naught, according to the property, the x of omega is multiplied with the e power minus j omega into t naught here. That is a time shift property. So the Fourier transformation of e power minus t mu of t is a 1 by 1 plus j omega. Okay, according to the time shift property, the x of t minus t naught, because it is a t naught samples is shifted, its Fourier transformation is, since x of t, you'll get the x of omega in frequency, and the t naught is samples is shifted, e power minus j omega into t naught. Okay, the given function is x of t minus t naught, and we know the Fourier transformation of e power minus t mu of t. The Fourier transformation of e power minus t mu of t is 1 by, actually it is a is there, e power minus a t mu of t, a plus j omega. So now it is in the e power minus t mu of t, its Fourier transformation. So a is a 1. A is 1, so the 1 by 1 plus j omega. 1 by 1 plus j omega. Got it? 1 by 1 plus j omega. So we need that is x of t minus t naught. X of t minus t naught. Got it? So by using this property and by using the e power minus t mu of t, the Fourier transformation means x of omega is there. So the x of t minus t naught, its a Fourier transformation is e power minus j omega into t naught, shifted value, and in the denominator is a 1 plus j omega, that is x of omega is equal to x of omega. Okay, so substitute this x of omega as 1 by 1 plus j omega, and it is shifted with the t naught samples is multiplied with the negative exponential with that t naught sample. So the Fourier transformation of e power minus of t minus t naught into mu of t minus t naught is e power minus j omega t naught by 1 plus j omega. It is a Fourier transformation. And another Fourier transformation also there. You have to find out the given function here. X of t is equal to mu of t plus 1 minus mu of t minus 1. Mu of t plus 1 minus mu of t minus 1, and the cos function is multiplied here. Cos 2 pi into t. Cos 2 pi into t. So cos 2 pi into t in exponential value is e power j 2 pi into t plus e power minus j 2 pi into t by 2. Okay. So its Fourier transformation is 1 by 2 into e power minus j 2 pi into t. So Fourier transformation of 1 is, we know, the 2 pi delta omega, and Fourier transformation of e power j omega naught into t is 2 pi into delta omega minus omega naught. So then finally the Fourier transformation of 2 pi into t is pi into delta, because already the 2 is gone, pi into delta, and here the omega minus, instead of omega naught is a 2 pi is there, so omega minus 2 pi, and this is omega only, my students, omega minus 2 pi and omega plus 2 pi is only the Fourier transformation of cos 2 pi into t. But what about the Fourier transformation of the multiplication factor mu of t plus 1 minus mu of t minus 1? Okay, for this, you have to find out, first of all, the equation here, the mu of t is in the exponential, mu of t plus 1 minus mu of t minus 1. We know the mu of t graphical representation is like this. Mu of t is 1, its magnitude from 0 to infinite, as a t is a variable. Mu of t plus 1, mu of t plus 1 means it's advanced function, so it is shifted towards the left side as a one sample. Its magnitude is also 1. Then after, mu of t minus 1, mu of t minus 1, mu of t is from 0 to infinite, the value is 1, and mu of t plus 1 is from minus 1 to the infinite, the value is 1, because advanced function shifted towards the left side. Now it is a delayed function shifted towards the right side. So it starts from the 1, its magnitude is also 1. And I need that it is a mu of t plus 1 minus mu of t minus 1. Subtract the two functions here, subtracting the two functions. From minus 1 to 0 and 0 to 1, the value is a 0 here. The value is a 0. The total is a 0. So mu of t plus 1 minus this function is 1 minus 0 is a 1 only. 1 minus 0 is a 1. So from minus 1 to 0 to 1, okay, the magnitude is a 1. And what about the from 1 to infinite? Here also the 1 is there. From 1 to infinite, the 1 minus 1 is a 0. So the function is a mu of t plus 1 minus mu of t minus 1. Only the magnitude is 1 from minus 1 to 1 only. And the remaining is a 0. So value is totally 0, and here also the total is 0. You can call it as a rectangle function. So the Fourier transformation of this function is, what is the Fourier transformation formula? The x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. Okay, what is x of t here? The value is from minus 1 to 1 is a 1 only. So the integration becomes minus 1 to 1. The x of t, the value is 1. 1 to 1. The value is 1 into e power minus j omega t dt. E power minus j omega t dt. Got it, my students? And what it is the Fourier transformation is e power minus j omega t whole divided by, with respect to, we are applying the time. So minus j omega is a coefficient, and 1 and minus 1. Upper limit is 1 and the lower limit is a minus 1. So now I am substituting the upper limit as a t value is a 1. T value is a 1. It becomes of minus j omega minus e power minus already there. Now you can substitute as a t as minus 1. it becomes of plus j omega by, already there is a minus j omega is there. So it is a Fourier transformation. Here the minus 1 by j omega e power minus j omega minus e power plus j omega is e power plus j omega. And that is equal to, take this minus as a term and subtract, change the sign here. It becomes of e power j omega. Negative sign is becomes a positive, and here the minus e power minus j omega whole divided by 2j I am taking here and multiplying with 2. Already the omega is there, you can write this as omega. So what is this function? E power jx minus e power minus jx by 2j is a sine function. So 2 by omega into sine omega. You see here the 2 sine omega by omega is a Fourier transformation of only this function. And what is the Fourier transformation of this function? Is pi into delta of omega minus 2 pi plus pi into delta omega plus 2 pi. Got it, my students? We got the two functions as consider this as a y1 of omega, y1 of omega, the x1 of omega here. See, by using the multiplication property, the time is protected. These two are the time protected. What is the frequency? Frequency can apply the convolution 1 by 2 pi into x1 of omega convolution with the y1 of omega. Got it, my students? So x1, they consider this x1 of omega is a 2 pi to x1 of omega is x1 of tau here as of the frequency 2 pi into tau by the tau, and the y value is considered as wherever that is a y1 of y of omega is there, omega minus tau is a tau, okay, omega minus 2 pi, omega minus 2 pi, wherever the omega is there, you can substitute that omega minus 1 and omega minus 1, that plus 2 pi is already there. Okay, my dear friends. So from this function, I am writing here that we got the two values. One is 2 sine omega by omega, and another one is pi delta omega minus 2 pi plus pi delta omega plus 2 pi. So according to the convolution of x of omega with the convolution of y of omega, consider this as y of omega and consider this as x of omega. So what is the formula for this one? Minus infinite to infinite, the convolution of the two functions. X of tau, y of t minus tau, d tau. X of tau, y of t minus tau, d tau. Okay, you see here, x of tau, y of omega minus tau d tau, because here the function is of omega. Whenever it is the t is there, let it be without confusion, x of t, y of t. Then only this is the equation. Now, instead of t, there is a x of omega with the convolution of y of omega. Now it becomes of integral minus infinite to infinite, x of tau, y of the t is now the omega is there, omega minus tau d tau. Okay, this is the second function. Then that is equal to integral minus infinite to infinite. What is the x of omega? We considered 2 sine omega by omega. What is instead of omega here, it is a tau is there. So 2 sine the tau by the tau. 2 sine tau by tau. And what is the y of omega here? Pi delta omega minus 2 pi. It is omega 1, right? Omega minus 2 pi plus pi delta omega plus 2 pi. So what is the instead of omega here? Omega minus tau. Replace the omega as omega minus tau. So it becomes of pi into delta of omega as omega minus tau minus 2 pi whole multiply here plus pi into delta omega minus tau plus 2 pi. Okay. Whole multiply and the d tau. Now we substituted the x of omega, y of omega in the convolution equation. And split the two parts as an integral here. As an integral. Integral minus infinite to infinite. 2 sine tau by tau. 2 sine tau by tau into pi delta function is there. What is the delta? Delta omega minus 2 pi minus tau into d tau. This is the first function. And here in this formula, there is a 1 by 2 pi into the convolution is there. So here there is a convolution is there, 1 by 2 pi into that convolution. So for every term, there is a 1 by 2 pi is a multiplication factor, 1 by 2 pi. So here also 1 by 2 pi is there for the first function. For the second function also 1 by 2 pi. The integral minus infinite to infinite is the same 2 sine 2 pi, 2 sine pi tau by tau is multiplied with a pi into delta of omega plus 2 pi minus tau. Omega plus 2 pi minus tau into d tau. So in this, the 2 pi is here, the 2 and pi is get cancelled, 2 pi and the 2 and pi is get cancelled. Okay. Now, the integral minus infinite to infinite, sine tau by tau delta omega minus 2 pi minus tau d tau. And another function is sine tau by tau, the delta of omega plus 2 pi minus tau d tau. Okay, my dear students. So I'm rewriting this function as integral minus infinite to infinite sine tau by tau and delta of omega minus 2 pi minus tau d tau plus integral minus infinite to infinite sine tau by tau delta of omega minus omega plus 2 pi minus tau d tau. Okay, my dear students. So in this function, you have to use this formula is there here. Integral minus infinite to infinite x of t delta of t minus t naught. Delta t minus t naught. Okay. Means that is whenever any integral with respect to the multiplying of delta function, the same signal will get x of t naught. If it is a x of t delta of t means x of t only. X of t delta of t minus t naught or k is there x of k. Whatever the sample is shifted in the delta function, at that sample only will get the x of t. So So x of omega is equal to, by using this, x of omega is equal to, the first term you can observe here, the first term, x of t is a sine function, is a sine, and delta is shifted with the omega minus tau is there, it is a minus pi, minus 2 pi, omega minus 2 pi. Here the t is, the function is a t, x of t, delta of t minus t naught, t minus t naught. So what is a t here? Nothing but the tau only. So sine tau, pi tau, and delta of omega minus 2 pi minus tau d tau is there. So using this relation, it becomes of a sine, the x of t. What is x of t? The sine only function, sine tau by tau is totally the x function. The t is there, wherever the t, the shifting value, what is the shifting value here? Shifting value is the t naught, so x of t naught. Here the shifting value in this, the delta function of the tau, the t minus, the t minus means you can take as a common the omega minus 2 pi here. And similarly for this function also, omega plus 2 pi, omega plus 2 pi. So delta function, delta omega is equal to delta of minus omega. So even it is a shifted function, the value is the same. Okay. So for that case, tau minus omega minus 2 pi, tau plus omega plus 2 pi. Okay. Even you can take the common here, delta of minus value, tau minus of omega plus 2 pi, and the tau of omega minus 2 pi. So finally, you get the x of omega is equal to the sine, the x of t function, and that x of t, the tau is replaced with the omega minus 2 pi, and here the omega minus 2 pi, plus, and here also the x of t, the function is the same, sine tau, tau is replaced with the omega plus 2 pi by omega plus 2 pi. Okay, this is one of the property, my dear students. The integral of x of t, the delta is shifted with the t naught samples. The t naught is taking as x of t naught. What is the x of t here? The sine tau by t, tau by tau. How many samples it is shifted here in the delta function omega minus 2 pi, and here it is omega plus 2 pi. So take the tau as omega minus 2 pi and omega minus 2 pi. The x of omega is equal to the function. The given x of t, the Fourier transformation of the mu of t plus 1 minus mu of t minus 1 cos 2 pi into t. Got it, my students? Next, it is a very important, my students. Determine the Fourier transformation of the triangular function. Determine the Fourier transformation of the triangular function. The triangular function is considered this as a slope and this is a b slope. A slope and the b slope. This is a slope and this one is a b slope. For a slope, minus t comma 0. It's x-axis, there is a minus t, and y-axis. They point on the x-axis means what is the y? 0 on. So minus t comma 0. A point on the y x-axis is the t. What is the y? Is a 0. T comma 0. And a point on the y-axis is a is there. What is the x 0? So x 0 comma a. Got it, my dear students? We got the 3 coordinates at this at the y-axis and the on the x-axis minus t comma 0 and t comma 0, and on the y-axis 0 comma a. For slope equation, the x of t minus or here we can say that it's a y2 minus y1 by x2 minus x1. Now you can consider this as x minus x1, or it is not the x minus x1, okay, is equal to y2 minus y1 by x2 minus x1 is a y is equal to mx plus c. So mx means here it is a x minus x1, y minus y1, y minus y1. Okay, and this one is considered as x is the t function and y is the x of t. Okay, so y is x of t minus here you can consider as a y minus y1 and x2 minus x1 is x1, and here it is a 0 and a means is a x value and the y value, x value and y value. Y is the y2 here, and this one x2 and the y2, and this is as considered as a x1 and y1. Okay, my dear students. What is the y1 here? The 0 is equal to, for this slope I am finding the slope equation. Consider this as x2 y2 and this one is a x1 y2. What is the y2 is a minus 0 by, what is the x2 here? The 0 minus x1 is minus t, so minus of minus t here, and multiplying with x, what is the x here? X is nothing but the t minus x1. What is x1? X1 value is a minus of minus t. Okay, simplify this function. X of t is equal to a by capital T into t plus t. A by capital T, t plus t. And now we can multiply this function as a t by t plus a1. T get cancelled. And finally, again, you can take the common of a t by capital T plus 1. Okay. This is x of t we got as a slope a. Okay, my dear students, it is the slope a. So x of t is equal to a into t by t plus 1. Similarly, you can find the slope b is a value, slope a, and now I am finding the slope b. In this slope b, what is the x1, y1? Consider this as x1, y1, and this as x2, y. Using the formula, the y is nothing but x of t. Y1 is a 0, and y2 is a minus y1. What is the y1 here? The 0 whole divided by x2. X2 is a 0 minus x1. X1 is a t, and whole multiply with x minus x1. What is the x here? The t. X-axis is the t functions, and y-axis is the x of t signal. T minus x1 is a t, capital T. Simplify this function. X of t is equal to a minus 0 is a 0 minus t is a minus t, capital T here, t minus capital. Multiply this function, at by the capital T, nothing but minus t. Minus into minus is a plus. Take the a as a common. A is a common, and it becomes of 1 minus t by capital. Okay, is x of t. The slope of this b, x of t is equal to a into 1 minus t by capital T, and the slope of a is a into t by capital T plus 1. Got it, my students? And now we'll get this function. How we'll get this function and how we'll get this function? Slope only we are finding. Okay. And we need only the 0 to, or the 0 to minus t to the 0 and 0 to the t value. What is the step function also? What is a step function? Okay. See, we got the slopes. Now this x of t is the graphical representation is converted to the mathematical. To get this, for this slope only, I need is a minus t and the 0. Is a given function x of t. This a slope. Okay, my dear students. Now I'm using here, first of all, mu of t is from 0 to infinite, the value is 1. Then I need the value of from the minus t. So advanced function can take, that advanced function is mu of t plus capital T. So it is shifted towards the left side with the t samples. Okay, but I need only this slope. So we can subtract these two functions, mu of t plus t minus mu of. Why mu of t minus? Because it is a 0 is there and here the 1. So 0 minus 1 is, we'll get the minus 1. Okay, but we need the positive slope only here. So then to get this slope, we can multiply the a slope with this mathematical equation of the step function. That is a mu of t capital T minus mu of t. So you can subtract this graphical representation mu of t from the mu of t plus t. So minus t to the 0, the value is here the 0 and the value is here is a 1. 1 minus 0 is a 1 up to the minus t to the 0. And 0 to 1 infinite, and here also the 0 to infinite, both the values is 1 only. 1 minus 1 is a 0. Its magnitude is a 1. Now multiplying the slope a and with this function, we'll get minus t to the 0. So first of all, you can see here the x of t is equal to a into t by t plus 1 is multiplied with the mu of t plus t minus mu of. Okay. For the second slope, the given function 0 into t is x of t signal. The b slope is multiplied with the what multiplication factor of the step functions. The same I'm taking that is a mu of t here, mu of t. And now I'm taking shifting towards the right side with the t samples. You get the mu of t minus capital T. Now, to get in between of 0 to t, we can subtract these two functions. Means mu of t minus t subtract from the mu of t. So mu of t minus mu of t minus t. Okay, then only we get from 0 to t is a 1 and the remaining function is 0. Then the total function of mu of t minus mu of t minus t is multiplied with the slope of b. See here, what is the slope of b? A into 1 minus t by t and is multiplied with the mu of t minus mu of t minus t. Got it, my dear students? we got the mathematical expression. The given graphical representation of slopes are the triangular function from minus t to the t. Then what is the Fourier transformation? Okay, from that you can find out what is the Fourier transformation. You got this equation. Then what is the Fourier transformation? Okay. Now, simply here, take the t as a common. 1 by t as a common, a by t, the t plus t, mu of t plus t minus mu of t. And here also the t, I take the common. 1 by t, a by t is there. And then the t minus t, capital T minus t. Again, you can multiply the t get cancelled, a into 1 minus the t only. Okay, mu of t minus mu of t minus t. Now we got the expression x of t is equal to the slope I can write as a by t, t plus capital T, and it is multiplied with mu of t plus capital T and minus mu of t. Okay, my dear students, listen carefully. It is very important in examination point of view also. Plus the second function you can see here, a by capital T minus small t, and this whole multiplied with the mu of t minus mu of t minus capital T. This is the equation we have after finding out the slope of A and slope of B and the unit step function multiplied with the slope of A and unit step functions with the slope of B, and finally to get the triangular function from minus t to the capital T. Okay, is equal to. Now I multiplied the t capital T inside the function. A by capital T, observe carefully my dear students, t plus capital T into mu of t plus t, and the second function, the t plus capital T into mu of t. Okay, whole multiply plus now I am multiplying this function. A by capital T is in outside, t minus t into mu of t and minus t minus small t into mu of t minus capital. Okay. Now I am rewriting the function again. A by capital T. Here the step is already shifted with the T samples in the left hand side. So here also there, nothing is different. You can keep like this only, the mu of T capital T and the mu of T plus capital T. Okay. Minus, now here see the T plus capital T and mu of T only. So I am multiplying the T individually, the T into mu of T minus capital T into mu of T. Okay, this is a total function. Plus here also A by T. Now I am rewriting the individually the T into mu of T and minus T into mu of T. I split the two parts here, but here multiply with the minus T, minus here, it becomes of plus. Small t is a plus and capital T is a minus. So T minus capital T whole multiply with the mu of T minus capital T. Nothing is Same. Here the t plus and here the t minus. Now we got all the functions exactly with the step function with capital T or with step function with small t. Step function is a delayed version or the advanced version. That is equal to what is the Fourier transformation? What is the x of t Fourier transformation? Is x of omega, and a by t is a constant. We know the Fourier transformation of mu of t. Fourier transformation of mu of t. Mu of t is or it is also called as a ramp function also when the t into mu of. So they wrote it as a r of t plus t like that. Okay, the Fourier transformation of mu of t is 1 by j omega. Mu of t, the Fourier transformation is 1 by j omega. Whenever it is multiplied with the t into mu of t, simply it becomes of a Fourier transformation is the square of the total function, 1 by j omega whole square. Now, if it is a shifted version, the t minus capital T or plus capital T, whatever it is there, mu of minus capital T. So what is the Fourier transformation here? The shifted function. What is the shifted here? Time shift property. According to the time shift property, it is e power minus j omega. Whatever the samples is there, it is shifted capital T by j omega whole square. Okay, using these formulas, apply here. So mu of t 1 by j omega, and it is multiplied with the t 1 by j omega whole square, and it is shifted with the plus t. Plus t means the t becomes of minus. So the total function here e power j omega capital T by j omega whole square. That is the first one. And t into mu of t. What is the t into mu of t? 1 by j omega whole square. 1 by j omega whole square minus, and again here the t into mu of t. T into mu of t. What is the t into mu of t? The capital T is there, and step function is 1 by j omega. So t by j omega whole multiply with plus a by t, and again you can write the Fourier transformation of this function. T into what is the mu of t Fourier transformation is by j omega minus t into mu of t minus 1 by j omega whole square plus, and now the t minus t mu of t minus t is the e power minus j omega t whole divided by j omega whole square. Got it, my students? Now simply multiply the a by t, or a by t is a common than the two terms. A by t is a common in the two terms. Here the e power j omega t by j omega whole square, and e power minus j omega t by j omega whole square. So I take the j omega whole square as a common for the two functions. It becomes of e power j omega t minus, not the minus is a plus, e power minus j omega t. Okay, in these two functions. And here the minus j omega whole square, and here also the minus j omega whole square. So it becomes of minus 2 by j omega whole square. And here the minus t by j omega and plus t by j omega is there. Okay, minus t by j omega and plus t by j omega. Both are get cancelled. The 0. Got it, my students? So in these two functions, j omega whole square is a common. So x of omega is equal to finally we got as a by t, and rewrite this function e power j omega t plus e power minus j omega t by the 2j omega, or j square is a minus 1, simply minus 1. You can write it as a cos function also. And the 2 by j omega, leave it like this. Okay. The given rectangle, not the rectangle, given the triangular function, the Fourier transformation is a by capital T e power j omega t by j omega whole square minus 2 by j omega whole square plus e power minus j omega t by j omega whole square. I can simplify these also. What it matters. It's very, very important in the examination point of view also. So we got the same thing. X of omega is equal to a by t e power j omega t plus e power minus j omega by j omega whole square minus 2 by j omega whole square. Okay. So still further, it is simplifying the function. We'll get like this. Okay.